show that x plus 2 is a factor of all of this stuff over here. So this one here is a really, really popular standalone question. So how are we going to answer this one here? Well, the factor theorem says that if x plus 2 is a factor of all of this, it means that if you put minus 2 into all of this stuff here, you should get the answer of 0. That's what it means. Doing just that will not be enough, though. There is a conclusion that we need to write, and then we're going to answer the bigger question underneath using all of this. So f of minus 2 equals brackets. Okay, I'm going to put in minus 2. Is it always the other one? Yes, it is. Okay, if you want to kind of see why, if you imagine you do this one here, it's telling you what you should sub in. Okay, and this one here, personally, I like to, just so there's no doubt, I like to sort of simplify the numbers just a little bit. Okay, and say then that is equal, that is equal to 0. Here's our conclusion. F of minus 2 is equals to 0. So by the factor theorem, x plus 2 must be a factor. And that's it to get a very easy 2 marks. What else can we do with it? Well, we can now do a little bit of extra work. We can say that x cubed plus 6x squared plus 3x minus 10, there must be a way that x plus 2 fits into this and it leaves something else. It leaves something that kind of shows that we can make a product, and eventually we can get 3 linear factors. So how are we going to do this? Let's have a go at doing a method that I quite like. So I'm going to say that it's possible to write this as the factor that we've just found. How do we know that? Well, because we show that the factor theorem works. And the other bit, the bit that I haven't found yet, is going to be a quadratic. How do I know? Because it's going to need it to get to x cubed. How many x squared times an x will give an x cubed? It will be just 1. Okay, it's not 2x squared, it's 1x squared, because look, that works. We can do another one while we're here as well. Do you see this minus 10? This is a good one to do. 2 times something, a number, is going to give us minus 10. Well, yep, it's definitely minus 5. Well, I have to assume there's something in the middle, and I don't know what it is yet. So for this one, I'm going to call it bx. Okay. Now, how do I find out what bx should be? What we're going to do is we're going to pick another piece and we're going to compare. When things are identical, it means that, for example, these 6x squareds on the left-hand side should be equal to all of the x squareds wherever they are on the right-hand side. I'm going to investigate x squareds specifically. I could pick the x. On the left-hand side, there are 6 x squareds. This should be equal to however many there are on the right-hand side. On the right-hand side, where are they? Well, a better question is, where will they come from? When I do this one, multiply by this one, that will give me an x squared. It will give me x times bx. It will give me b lots. Okay, this is a 6, this is a b. It will give me b lots. Anything else? Will they come from anywhere else? So, yep, they will come from one more place. So, a number times an x squared, 2x squared. That will give you a 2 there. So 6 is equal to b plus 2. In other words, b must be 4. Let's use this information now. So x plus 2 times x squared plus, what was the answer? 4x minus 5. Can you do anything else? Yes, you can. So we can break it up one more time, and we should find, with a bit of detective work, that this here is going to be a minus 1 and a plus 5. And that's it. Okay, we have broken up our cubic using a factor that we found with our correct technique and a little comparing coefficients. There are other ways you could do it. We have our final answer here. So here we go then. Let's have a go at our second one. We're going to have a look at f of minus 3. So bracket cubed minus 4 bracket squared minus 39 bracket minus 54. And we are going to put a minus 3 in on these ones here. And when we do this, we should end up with a minus 27 minus 36. This is going to be a double negative, this one here. So this is, what's this? This is 39 times 3. So that's going to be plus 117 minus 54, which is going to give us a 0. And f of minus 3 equals 0. As per the factor theorem, if f of minus 3 equals 0, x plus 3 is a factor. Okay, so that's the first bit that we're going to do, the same like before. Let's have a go at doing our, let's do some long division this time. So we're going to do x cubed minus 4x squared minus 39x minus 54. Let's get rid of that one there. We were doing x plus 3 was the factor that we knew about. So let's try it again with a different method this time. What connects these? It's x squared. So x squared goes up here. X squared times x gives us x cubed. X squared times 3 gives us a 3x squared. Okay, long division, we're going to cancel those ones out and we're going to subtract. So that's going to be minus 4 minus 3 gives me a minus 7x squared minus 39x minus 54. Let's go again. What links an x and a minus 7x squared, because that's the biggest power now. It's going to be a minus 7x. So minus 7, and this one gives us a minus 7x squared. And what's that? That's a minus 21x. Okay, these should cancel. Minus 39, watch out for the double negatives here. Minus 21 gives me minus, how were we writing it before? We did it in purple. Let's do it in purple again. So this gives us a minus 18x minus 54. And we should have to go just one more time. So what links minus 18 and x? It's minus 18. Okay, when we multiply this back, it gives us minus 18x. And it gives us minus 54. In other words, there's no remainder. So let's zoom out. We're going to say then that all of this business can be written as x plus 3 and then an x squared minus 7x minus 18. And we were going to write this as 3 linear factors. When it's a quadratic, it's much easier. So if you play around with that one there, you should get a minus 9 and a plus 2. So I hope you got this other one okay by this method, or otherwise, there we go. That's the factor theorem and our long division.